Did you want to learn how to make generative art animations and didn't know where to start? Then this is the video for you. In this video, I will show you how to get started with generative art with minimal setup using TypeScript. We don't need any frameworks or libraries or even a server. It is that simple. This is what we will be creating in this video. Pretty looking balls bouncing around. I will show you how to set up the project, how to design our program, how to animate and make things pretty with some color palettes. What you will see is the edited video of the live stream. And let's create readme file. So I will go through the setup. So this is the setup where you create a TypeScript project and set up the HTML and then the compilation and auto loading and that sort of thing. The second one is design of the program. So what sort of classes that we create and how it all works together. That's the second thing. Third one is create basic animation. And then fourth is make it pretty. And then fifth is a summary of what we did. So this is that's the agenda. Oh, this is what we're going to do today. So the first thing is to do is you initialize this folder, which is empty, with TypeScript, and it will generate a tsconf config.json. We don't have to do anything over there. We just leave it as is, and then we will create an HTML file. So this will be index.html, and it will have HTML, then head, which has to have one, then a body like this, and inside the body we will have a script tag with a source app.js, and that's it. So this app.js is what we're going to generate with TypeScript. So let's create the app.ts. We can get the TypeScript to tsc -w. That would watch and compile stuff. And over here, yeah, still in the same folder, we can open the index.html. So there's nothing to see because we don't have anything in there. So this is the setup. We're still in the setup. We're here. So let's create a function. Bootstrapper. This function name, you can call it main, you can call it anything, it doesn't matter. So let's give it a width. All our drawing is going to happen on the canvas, so HTML canvas. So we're going to be using HTML canvas document.create element canvas. So if you look at MDN HTML can document create element. Right, we just created a canvas. It's a good idea to check. So we're going to check if the canvas is valid. If it is not, then we're going to return. And then document.body.append child canvas. So that's the canvas that we're going to right. So now all the operations are done on a something called the context. If you have done Flutter, then you know that everything is drawn on the canvas, and in HTML it is done on the context. So we need to acquire a context from this. So we call it ctx canvas.get context and then 2D. So that will give us a 2D context to do all kinds of operations on. Like if not ctx, then I'll check return. For whatever reason, if it cannot create one of these things, then we cannot go forward. That's why we are returning. I'm gonna set up everything inside something called the simulation. So simulation will contain all our animation, game or whatever that we're gonna do. Think of this as like the universe. So the universe has everything inside it. There's nothing outside of it. So it is something similar. You can say const sim is new simulation. This is a class that we're gonna create. That's why it is not still defined. So we will define it in a bit, and then we're gonna set up the update. So once we have a simulation, so that's the game that we're gonna create. We need a way of updating. So you know that any game will have update ticker, things like a frame rate. So things get updated and drawn to the screen at some sort of a frame rate. So let's say update frame rate is 60 frames per second, and then we can call set interval. So we can say mdn set interval. There we are. Right, so we need to have a function which will do something, and then the delay. So that is the frame rate is the number of frames per second. So we're gonna do that. So that will give us the delay in milliseconds. Now inside this, what we're gonna do is we're gonna update. Now we need this, and then draw. Of course, this is not defined, so that it's not gonna work right now. But since we have this, so we can say run. So that is bootstrapper. What we created was a bootstrapper which will create a canvas element and then append that to the body of the document, which is the web page. And then we get a context from it that we can draw on. And we should pass the context onto the draw method so that things can be drawn on it. So that's great. So let's go and define what the simulation is. So that can be achieved by simulatable, something like that, and then draw. These are the two things that we want for something to be simulatable. So then what we can do is to create this class simulation implements And this complains that I have not implemented the whole interface, so that I will let it do that. And this would be a to do, and this would be something that we can draw. So let's have a simple so we are getting the CTX, so we can do this ctx.fill style is black, and ctx fill rect 0 0 this width, this height. Of course these are not set up, so let's go and create this simulation constructor, private width dot number, private height number. Okay, so let's move this over here so we have more real estate. Okay, so now when we create a simulation, we need to send width and height, which actually we already did that. So this is the correct thing to do. Right, now this sets a private member variable, width and height, and we can retrieve these things like this. This is great. So what happens here is that let's do a quick summary. We created an interface that defines the behavior of a simulatable object, which has two methods, update and draw, and then we create the simulation which implements that interface. So the simulation has the behavior simulatable. Now in the bootstrapper, we create this object once, and then we have this set interval, which is a periodic function that will get called at this duration. So every 60 times a second, it will update the simulation and then draw to it. So there's nothing to draw apart from a black rectangle, because that's what we did here. So if we go into index and then refresh, that should be available. Okay, great. So with the tsc -w, it automatically compiles, but it doesn't load anything to the HTML page. As you can see, this is a file. There's no let me make it bigger. So it's a file, and I'm just using it from the disk. There's no server. Right. Okay, so we now have the simulation, but without anything in it, apart from the blackness, just like the universe. Right, now we are here. The other thing we would need is actual objects. We're going to create something called particle, which is also simulatable. So imagine this as like, so we just created the empty universe, and then we are just now creating the atoms on it. So class particle implements iSimulatable, and I will let it implement that interface, and this is to do as well. So we just created a particle which has the same behavior, and we would be able to have particles in this simulation. So what we're going to do is particles Right, so we have an empty array of particles we will just draw. Right, so in our constructor, you need to create some particles. So let's say we're going to have some number of particles. Constant number of particle count is 100. Okay. So here we're going to create that many number of particles. Particle count, and okay, now we have these particles, push, and then we create a particle, new particle, like this. Right, so now we have we are creating number of particles all over here, and then what we have to do is to for each update. So in the update method of the universe or the simulation, we update every particle. Right, so update is the thing that we do to compute the next position when they move. So particles move, they change color, they change velocity, they change lots of properties, and all these computations are done inside the update. And in the draw method, it is the same. So we have the background and then draw everything. So this is just again particles dot for each p dot draw context. Okay, draw background. This is all good, but there's nothing to see because our particles don't do anything. Our particles are empty. They don't move, they don't have a color, they have nothing. So the next thing to do, let's give the particle some properties. So say x is 0, y is 0, and dx is 0.1, dy is 0.1. So what are these? X and y are the positions, and the dx dy is the, you can call it the velocity, because this is the amount by which the position will change in a given update. The velocity is defined by the same. So velocity is something like meters per second. That means in every second this object moves how many meters, whatever number of meters. So we are calculating in pixels with pixel values. So, and the dx defines that the difference in the motion in x and y directions, because this is a 2D thing that we're creating. Okay, so draw something. So the first thing to do is to fill style, and this would be something like a color. So let's make it red, right? So all the objects will have this color, and then ctx begin path, ctx arc x. So let's get to this. There we are. Now it should have an example. So there we are. Arc is what I'm going to use to draw a circle. Usually arc is useful like drawing a segment, or a little part of this circumference, but we can use it to draw the whole screen, whole circle. So these are the parameters. X and y are the center of the arc or the circle. Radius is the radius, start angle, and then end angle. That is, so for an arc you could be drawing from here to here. So that is the start angle, and this is the stop angle. But since we are drawing from 0 to 360, we're gonna do it like this. So this y and we're gonna have 0 to start. Sorry, this is the radius. Yeah. Do we have a radius for our particle? No, we don't. So let's create a radius. Something like 10. Okay. So this would be this dot radius and 0.0.2 times math dot pi pi. Okay, and then ctx fill. Right. So this should draw something on our screen. Let's see if it does. Yeah, it is drawing at 0, 0. One thing to do here is to randomize these circles. So this can be done by, let's create a constructor here. So constructor like this, and then we're gonna set x to some get random float 0 to w. W is the width, so we need to pass that in. The height as well, right? So we don't have y is get random float 0 to h. Now you might ask, what is get random float? Well, we haven't defined it yet, so we're going to do it. Function. This has something like minimum number and a maximum number, and then it returns a number. What does it do? It returns math.random. Math random always gets you stuff from 0 to 1. It never gets you 1. It is getting to close as possible to 1. So that's why we need to scale this up. So we have something like this, max minus min, and then we just gonna add min. So which means that our random numbers will be from minimum number to maximum number. Okay, let's create another one. Get random int min number, max number, and number, and return math.flow and get random float min x. Okay, so we have two utility functions. So this would give us x and y location, and also we can make it have a random radius as well. So let's have it this dot radius get random float between 5 and 20. How about that? Also, we can get to this the velocities when we try to animate. So let's take a look at our to-do. We are still in the design of the program, so we're just about to get to the basic animation part. Now it should do something. So as you can see, when we run the program by refreshing the web page, it draws circles everywhere. So that's good. That's good. So now next thing to do is to see if we can animate. So now you probably have a good idea what we're going to do. So in the update method, that we can do such things like change the position. So the position, this is x, we can do something like this, dx, which gives us the new position. So y is the same, this dot dy. Now what should happen is that these should move with this velocity. So the velocities would be the same, wouldn't change. Yeah, they all move at the same speed. So this is not what we want. We want different speeds. So let's have it like 0.1 to 0. Let's say 2. It's a little bit smaller. Actually, we can do something like this: minus 0.2, 2, okay, and same for dy. Now they are moving randomly because they have random velocities. Good. So this is all good, but they are moving away from the screen. So they just, after a little while, they will all move away from the screen because the velocity is making them move from one side to the other. Okay, so what we can do here is to have a little bounce check. So that would be something like if x, so x is the center of this circle and plus its radius, if that is greater than or equal to the width of that. So basically we are checking when a circle moves very close to the edge, is it hitting this wall? That's what we are checking. If that is the case, what we want to do is we're gonna revert our velocity. So the velocity was to go this way, we're gonna revert it that way. Okay, and then we're gonna also set this radius. So similarly, we can do this for the other side, on the 0 side. So that would be something like if this x minus this dot radius, because x runs this way, so x is over here, and the value of the radius is minus that amount, then is 0. If it is 0, then we are saying that we know that the value is the circle is touching the wall on the left side. So again, dx is minus dx, that is reverting the velocity, and then we're gonna set the 0 plus this dot radius. Hang on, this part is wrong, because this what we want to do is to this dot w minus this dot radius. Okay, I made a mistake there. So because on this side, if it is touching, we just don't want to draw a circle halfway, so that should be the w, which is this, and then radius, which is the radius of the circle. So if we draw it somewhere here, then it will just touch. On over here, it's the same. On this side, if we move x to the radius distance and then draw the circle, then it will just touch on the wall, right, wall on the left side. So this is the same for vertical side. So we can just copy this and update it. It should be y plus radius greater than or equal to the h. So we are checking the lower wall, and this is the y velocity, and h, and then this is y again, y, and this is y. Okay, that's the top wall. So with these two, it should bounce back. when it hits the wall. So as you can see, as I said earlier, we have lost all the circles that we had. So let's see. So as you can see, they bounces off these walls now, right? They hit the wall and then bounce back. So all the circles will just stay inside our square. That's the whole idea. So I think we can. Okay. Good stuff. So now we are here. We just created a basic animation that just moves about, and now we're gonna make it pretty. So now we're gonna do this. Right. So in order to make it pretty, we're gonna set some colors. So that means that we're gonna have a color property over here. So so what we can do here is to send in a color in the constructor. So that would be something like private color string, right? So that will set a color. How are we going to use the color? That is the next question. So when we draw something, we need to have the color set. So right now this is the simulation. We can close this, fold this. Excellent. In the draw, we draw everything as red. So let's say this color. Right. So that's what we want to do. We're going to set individual colors to each of these particles. So our update function that is done, draw, we set the color, that is great, and the constructor looks like this. So now we have an error over here, we need to set a color. In order to do that, we need to have a simple color palette defined. So this can be done something like this. First, color palette, something like this. It's an array, and then we will have some colors over here. So something like red, green, blue, orange, purple, something like that, right? Select a color in random. M equals get random int is the color palette. We have one color palette, 0, and its length. We know that how many colors there are in that. So we just selected one index from that, and then we're gonna use that color. So that would be something like this, right? Which means it will get colors like this. So this is okay. This is not the best, but it is it's fine. But we can do better. So that's what we're gonna do here. We can have something like this. So this is Adobe Color Palette website. So you can just select something like this. I don't know, random stuff like this, right? Let's say if it is this color palette that we want, then we can copy as XML. And this is ugly. We got to do some editing. So I'm gonna do it like this. No, not like that. Just get rid of those two tags, and we just don't want anything other than this part. So we need that, we need this, we need this, and we need that. Now we just got ourselves a color palette, then wrap it like that. Right. Now if we go and refresh, it doesn't do anything because we are selecting the color. So right, what we can do here is that we're gonna select at every run we're gonna select a palette, which is K, which is get random int from 0 to color palette. Let how many palettes there are, that's what we're gonna do. So we're gonna get a random palette from here, then we can call it palette, color palette K, right? And then here we're gonna go from palette. So here we're gonna select a color, right? That's what's happening here. So pal. So we're going to select a color in that palette we selected. Okay. Now, if we refresh, we set the color palette, right? So that's great. So we can do the same thing again. Let's say right. So if we go to our web page again, and then yep. So we have another one. So I'm going to paste here a few of the palettes I created earlier. It's the same method. There's nothing different about this. So just paste some of these, and now we should have various different colors. Okay, so this is a nice little experiment that you can quickly get up and running. So once you have that, you can do various things with it. You can decide not to draw a background. So for example, in the simulation, we are drawing a background with black. So that erases what was previously there. So if we don't do that, it will have something like this, right? So you can leave it like that, and it will go in a straight line. And then you can experiment in the way that, okay, why should we go straight line when we can change the velocity or the direction? So that, you know, various things can be done with this. So that's up to you. This is a kind of a basic thing that we can get started with, and then experiment and create nice, wonderful generative art with this framework. So let me recap. So we are here. That's a summary. So first thing to do is just to initialize the TypeScript project by tsc -init. That will create a file like this, tsconfig, and it will have, you know, some various parameters that you don't have to change any of it, and you don't need Node.js or anything, any server, Express, nothing. And then you create an index file, index.html, which loads up this JavaScript that is generated by TypeScript file that we create. Excellent. So this is the file that we see over here. If you look at the page source, it will have that page source. Excellent. Right. So that's that. And then we go and create our TypeScript file, which is TS, and we created a bootstrapper. So this is the function that would be called when the script is loaded. So it's called the bootstrapper, and then we run it over here like this. And in here we created a canvas, and then set up the canvas so that it loads up something called simulation. Simulation is an object or a class that has the behavior of a simulatable object. Simulatable object has the behavior that it can be updated, and also it can be drawn. So those are the two different actions the simulatable objects can perform. So in the simulation class, we implement this behavior, and in that we create the background first. We draw the background, black rectangle, and then we draw all the particles there is in this simulation. So the simulation has a list of particles that we create when the simulation is created in the constructor, and we randomized most of the parameters. So we create a number of particles and then add to this list. And on our update function, we update all of the particles, and then in our draw function, we draw all our particles. Okay, great. So these things can be changed, as in like you can have some sort of a condition saying that, okay, I'm only going to draw the particles that has some property that you just added. But we don't have that because this is very simple framework. So in there we draw all the particles, but you can filter them out if you want. Right, so that's the basics of the simulation. And going one level deeper, which we have the particles. Particle is an object that has a position x and y, and has velocity dx and dy, and also has a radius. So we set up all these functions, all these properties as random values when they are created in the constructor. Constructor also get the width and height and the color from when it is created. Okay, in the update function, we update the position. In the draw function, we draw the particle. So we start with the color, begin path, draw an arc, and then fill it. That's great. In the update, we want to keep all the particles or this particle inside the simulation itself. So we have a bounce check after the velocity is applied to the position. So that's that. And I have a few utility functions to get the random numbers. This is the simulation object, and that's the constructor. And then we created some color. First thing to do is create a color palette array. This should be called color palettes. Should be called color palettes. So we should have, now I made an error, but it should be called color palettes, and each of these elements, which is an array itself, is a color palette, and a palette has a number of colors. So since these palettes have matching colors, it will look better when we select one palette for that given run of the simulation, and each of the particles will have a color from this palette. It wouldn't have colors from this palette and that palette. That would look odd. That's what we are doing. So in the simulation constructor, we do that here. We select a palette at random. That's the palette. And then we set a color from that palette to each of the particles generated. So that's what's happening here. Right. So once you have that, we get nice looking animations like this. So thanks for watching. If you enjoy my content, please like, share and subscribe, and have a good weekend, and see you next Saturday. Thank you very much.